Section 4 is going to talk about one of the unique things with a circle as opposed to some of the other shapes is a circle has its own distinct equation. And if we have an equation, we can do a lot of algebraic things with this geometry concept. So the equation of a circle that has a radius r and center hk is given by this equation. And there's a couple of key features. So please note that it is subtraction in here. So if you end up with negatives, coordinates for h and k, you would have a minus, it will end up plus. This is radius squared. One of the biggest mistakes kids make when they're looking at the equation is they forget to take the square root when asked to find the radius itself. And so here's a simple little picture. Here's my center, the length of my radius. Again, that seems like we might be going to need the distance formula in our future. So there's lots of different ways that we can actually come up with writing the equation of a circle. I can give you something like write the equation given the radius and given the center. Now the origin is 0, 0. So in this case, if we write our equation and we fill in our center, h and k, and we fill in our radius, we've very quickly and very easily written the equation of a circle. So hk, 0, 0, comes from here. My radius is at 4, and of course if we clean that up a little bit, x minus 0 is just going to be x, y minus 0 is just going to be y, and it equals 16. And that is the recipe for writing, drawing, graphing that specific circle. We can also talk about a radius of 5 and a center not at the origin. So again, if we look at our formula and we fill in what we know, what we need, these 3 spots with these 3 pieces of information, we can very quickly and very easily write the equation. Now here's what I was talking about. I have y minus a minus 8. And so when I go to clean this up, this stays as x minus 1 squared plus this is y plus 8, the quantity squared, and it equals 25. And that is how you write the equation of a circle. Another way that we can write the equation of a circle is given a graph. And so in this graph, we have our center, easy enough to see, but our radius is not given to us. And so the first thing we need to do is we need to use the distance formula to find that radius value. And so r is going to be equal to the square root of the x's subtracted plus the y's subtracted squared. So 2 minus 4 is going to be minus 2 squared plus 4 minus 8 is minus 4 squared. Please be very careful with your subtraction signs. Minus 2 squared is 4 squared plus 4 plus 16. And so I have the square root of 20. Just as a tip, you want to leave this as a radical. And you'll see why in a second. And so now it becomes very simple to come over and say, well, I have x minus 2, the quantity squared, plus y minus my k, which is 4, the quantity squared, is equal to my radius, the square root of 20 squared. And this is why we want to leave as a radical. So I don't need anything to clean up here. So my x minus 2 squared plus my y minus 4 squared. The square root of something squared effectively cancels because those are opposite operations, and this is my answer. Had you done a decimal approximation and then squared it, you would have introduced a rounding error in your answer. We can also graph circles if we're given the equation. And so from this part, I get my center. Remember, it's x minus h plus y minus k. Well, when I see a plus, that means it was minus minus. So my center is at minus 6. There's nothing being added here, so it's at 0. Remember that this is r squared, and so my radius is 5, the square root of 25. Don't forget to take that square root. So to graph it, I have negative 6, 0, and then it's a matter of simply counting my radius in five units in each direction. Go straight up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Bad graph. 1, 2, 3, 4, 5. And connect the dots to graph your circle. Not an exact science, but it works. Now this example is interesting because it doesn't look like we have enough information at all. So if we think about a circle who has diameter endpoints of 1, 4, and negative 3, negative 2, we need to find the center and the length of a radius. So, couple of steps. 1, the center is the midpoint, and we have a formula for that. And so I can take those endpoints and say 1 plus negative 3 divided by 2, and 4 plus negative 2 divided by 2. I come up with negative 2 over 2 and 2 over 2 for a center of negative 1, 1. Now I always like to go back to my given information, and in order to find my radius, I'm going to use the distance formula and find the entire distance and then divide by 2. I could do the distance from this center, which I now know is this, to one of the endpoints, but what if I got that center wrong? Then my answer would be wrong. So I'm going to go back to my original and say the distance of the diameter is the square root of 1 minus minus 3, protect your negatives, plus 4 minus minus 2, the quantity squared. 1 minus minus 3 is 4 squared, plus 4 minus minus 2 is 6 squared. 16 plus 36, I have the square root of 52 for my diameter. That means my radius is the square root of 52 over 2. And I'm going to go ahead and leave it like that. If I go back here to my center, my equation is going to be x minus minus 1, the quantity squared, plus y minus 1, quantity squared, is equal to the square root of 52 over 2 squared. I just inserted everything into the formula. If we clean it up, x plus 1, the quantity squared, plus y minus 1, quantity squared. If I square top and bottom, the square root of something squared is just the 52. Square root of 2 squared, rather, is 4. And so that is the equation that goes with that diameter. Now, if I talk about whether points are on, in, or outside the circle, it has everything to do with how they satisfy the equation. So if this sum, so our equation ends up being equal to the radius, then we are on the circle. If I end up with some value that is less than my radius squared, then I'm inside. I came up short, and if I end up with some sum that is greater than the radius squared, then I ended up outside of the circle with that given point. If something equals out in an equation, it means it's a solution, is an ordered pair that satisfies that equation. So this is a matter of substitution. Here's my x, here's my y. If I have 2 minus 1, the quantity squared, plus 4 plus 1, quantity squared, how does that relate to 16? Is it going to be equal, less than, or greater than? And so I have 1 squared plus 5 squared. What happens? Well, clearly, this side is going to end up being 26. It is greater than, therefore this is outside of the circle. If we graphed it, that point of 2, 4 would end up being outside of my circle. If I go through the same thing with 2, 2, and say 2 minus 1, the quantity squared, plus 2 plus 1, quantity squared, how does that relate to 16? I would end up with 1 squared plus 3 squared, and 16. And again, clearly this side, 1 plus 9, is going to be less than. This one is going to fall short and be inside of the circle. This last example, if I have 1 minus 1, the quantity squared, plus 3 plus 1, the quantity squared, again, just replacing x and y in the formula, how does that relate to 16? 0 squared plus 4 squared pretty clearly is equal, therefore this is on the circle. So go ahead and give the practice questions a try that follow this and tune in for part 2.